Hello, everyone. Good morning. I'm Felipe Hoffa. I work for Google. Thank you for coming to my talk today. I've been a Google developer advocate for the last 4 years. Before that, I was a software engineer for Google, and then they said I was too pretty to stay behind the keyboard. So now I go around the world. I'm in videos, I'm on social media. And yeah, I have an amazing job, and I try to bring you as much as we can from the Google Cloud, things that you can use. And today we're going to analyze GitHub's data, open source code. I guess that's why you came to this talk. And this computer turned off. I will turn it on again. OK, so to get started, what do you see here? What is this? GitHub? Yes. What else do you see?
22 contributors.
Very good. Metadata. So, yes, so what we have here is first code. But inside the code, we have a lot more interesting facts. We have a license. We have imports. We have things that come from the future. In this case, this is Python code. We also have more metadata. We have 22 contributors. We have a number of forks, number of stars, a lot of data. So when I see this, we can see code as data, not only code, but also all the metadata around it. Or as a friend says, told me to put data very big, because this is big data. There's a lot that we can analyze here. So who wants to analyze GitHub? Well, I guess that's why you're here. But for example, project maintainers. If you own a project, how many people have their own projects on GitHub? Good. Excellent. Excellent. If at any time you want to change any of the analysis I'm doing to do it on your own project, we can do it in real time, and we can see what happens then. Good to see so many maintainers. So you might want to know the popularity of your project. Vanity metrics are nice. It's nice to see how the number of stars, contributors, everything goes up. But you also want to see more about these people. It's not only about the number of stars. It's who are these people, what are they interested in, what other projects they like. Change management, how many people will you break if you change your project? Is your project healthy? Are you resolving issues on time? How long does it take to accept a pull request, etc. Also project users. Everyone uses GitHub, but then when we want a change, it's nice to be able to request changes based on data. Not only what you want, but for example, telling the project maintainer how many people would benefit from that, or how to ask things in a way that will be actionable, or what other projects to follow, what other related projects we have. And even before becoming a user, how do you choose a project? How do you choose the most healthy one, the most popular, what related projects are out there, etc. And of course, data lovers. This is a super interesting data set that it's open for anyone to analyze, find facts about your favorite languages, security if you want to fix bugs at massive scale. Now you can do it, and I love doing this kind of stuff. We are going to be reviewing 3 main data sets that we have available. Right now, anyone can go and use these 3 data sets right now and get insights. GitHub Archive. This is an archive of all of the events from GitHub, hour by hour. Last time I counted, it was 8.7 billion events, but it's still growing, so the number continues to go up. GHTorrent is a similar project to GitHub Archive, but it brings more metadata. So for example, you can reach everything that a user wrote about themselves on their profile, so you can start getting more metadata about your logins. And you can get real-time updates from this one. They are publishing them to PubSub. And also one of the most interesting data sets I have here is just all the open source code on GitHub, at least everything that has a proper license and it's kind of popular. We have it stored at Bigquery. And now that I mentioned Bigquery, who knows Bigquery? Yes. You like it?
Yeah.
Excellent. Yes. But let's go back to 2012, when Ilya Grigorik started collecting all these events from GitHub. He's another developer advocate at Google. He started recording these events, and then he wanted to do something with this data. So he left them available on a web server. If you wanted to download any of these files, you just get the hourly file. Each one is about 5 megabytes of compressed data, and compressed 40 megabytes. And downloading this will take you nothing, less than a second to get one of these files. But the problem happens when you start analyzing this at a massive scale. You don't want to analyze 1 hour of data, you want to analyze 7 years. And then we're dealing with 2.39 terabytes of data, more than all the billion events, et cetera, depending on which date do you choose. In this case, it multiplies to less than what I have because I started with January 1st. My sample file is from January 1st. There wasn't much activity. And that's when Bigquery showed up to solve Ilya's problem. This is a product from Google Cloud that we made available around that time, 2012. And it has some pretty nice characteristics. One, it's fast. You can analyze terabytes of data in seconds, and I'm going to show you how that works here. You only need to know SQL to use it. You can scale from bytes to petabytes. It doesn't matter how much data you have. It will handle it. There's nothing you have to pay to keep it on. It's always on. You just put your data there, then you pay for storage. If you write queries, you pay for each query or not. It can work with your favorite software, Tableau, R, Python, etc. Google Data Studio, that's a new one that I can demo for you later. And this is from last week. They announced that finally Power BI has a BigQuery connector. Any Power BI fans? Well, now you can connect it to BigQuery. And two things that are super interesting about BigQuery. One is that you can share data that's inside. If I have a big data set, I can set the permissions so any of you can analyze it. So you don't need to download anything. You don't need to. You can just go to the web UI and start querying, or go to your favorite software and connect it to the table. And everyone has a free terabyte every month to pull off these queries. Everyone also has 10 gigabytes of free storage if you want to share. And then you can share data ready to be analyzed without worrying about any costs. Whoever's writing the queries pays for those queries, but they also get a free terabyte, which is awesome for open data. Next slide. So first, let's look at the stars. If you look at the sky, there are millions of stars, and what I'm trying to show here is that it's all about where do you want to focus. There is so much data available that looking at any ranking, looking at any portion of the sky, will only give you a fraction of it. But what's interesting is your ability to focus on wherever you want to focus. Start doing your own rankings, start looking at the people you're interested in, etc. And when we look at the stars on GitHub, we can look at what projects have received the most stars. So for example, just to dive into, let's do something. What are the top projects by stars in 2016? And I have, instead of using the slide, I will do it live. This is the Bigquery UI, web UI. Anyone can use it. And I can type my query here. And basically here I'm asking for each repo, give me the count of stars in my GitHub Archive table. So I have here the 2016 table, which has a lot of fields. And 2016, we got 320 million events, 700 gigabytes of data. And if I want to count the stars, I just need to look for the events that are a watch event. I have my table here, grouped by repo name, ordered by the count, give me the top 20. And this is how long it takes to go over all these events, which is pretty quick. And we get that the top project was Free Code Camp. And it has a lot more stars than the second project here, the Google Interview University, free programming books, Vue, TensorFlow, of course, Facebook, you don't know JS, Apollo 11, yeah. Those were the top 20, but not really. And this is something that I want to show you. What happens when you start projects? I'm not signing it in this one. But every time I press start, I can then unstart it, and start it again, and unstart it, and start it. And as we are analyzing a log events, that will show up like a lot of stars. So this is when you need to start doing tricks. Whoever is doing a ranking based just in the number of watch events is getting a number that might be gained. So instead of doing that, we can count the distinct actors that were doing the starring. And then the ranking changes. Let's wait some seconds for it to run. Boom. So yeah, FreeCodeCamp did not get 100,000 stars last year. A lot of them were duplicated, people starting the project many, many times. So you have to pay attention to that because some projects get thousands of extra stars by this measure. I don't know why people do it, but they do it. So yeah, we see this. And not all stars are equal. Like one thing is knowing how many stars your project has, which is cool. It's good for your vanity. But each star comes from someone. Each star comes from a new developer, from experienced developer, from a Java developer, Microsoft developer. And you can start also learning stuff about them. So if we compare FreeCodeCamp to TensorFlow, FreeCodeCamp got way more stars than the TensorFlow project, and there were about 3,000 people that start both. But you might want to see more details about them. So with this query, for example, if I type it here, you can see the code. Do I need to make it bigger? Yeah. With this query, what I'm doing is I'm looking for each of the stars, who's the user behind, and looking at how many repositories these users have seen, how many issues have they written, how many pull requests, how many pushes, et cetera, and now I can get way more stats about these stars. And you can see, for example, that the age of the users, FreeCodeCamp, are about 1 year old in GitHub years since they started doing GitHub stuff, while TensorFlow starters are in average 2 years old. So we are talking about a more mature audience. FreeCodeCamp starters have started 12 projects, TensorFlow 80, the number of issues they've written, comments, the number of pull requests. It's a different audience. So now we can start doing rankings instead of just by the number of stars. We can look at, let's do a ranking only looking at people that have written more than 20 user comments. This will show us that they have more experience, they've been more involved in GitHub. And FreeCodeCamp in this case, instead of having 170,000 stars, goes down to 3,000. So this shows you that when you're doing a ranking, you may want to have maybe the ranking of experienced people instead of new people, wherever is what you are looking for. So we do this ranking when we rank things this way. FreeCodeCamp is not any longer the top project. The top project becomes Yarn by experienced people. And that's a pretty, you need to be able to look at what you want to look, to focus on what you want to focus. And with these kind of queries, you can do it pretty fast. Now, if you want to see things they start, for example, this one I did with TensorFlow. With this query, you can see that I'm looking for everyone that started TensorFlow and did not start FreeCodeCamp because too many people started. And then I'm looking at for projects that other people start, that these people start. So the 22,000 people that start TensorFlow, they also start TensorFlow models, Caffe, Keras, Google Interview University, Scikit-learn, and Microsoft CNTK. I don't know if you want to run it for your project, just to see what they start.
My project's done at 6,000.
Oh, who has a nice number of stars? Okay, let's do it for VS Code. It's okay. Don't be shy. So for example, VS Code instead of TensorFlow. So people that start Visual Studio also start in 2016 TypeScript and Yarn and Vue and Facebook React. And you start finding things that people are also interested in. Also, they're pretty interested in Node.js, in Atom, and TensorFlow. It's also interesting to, one day you will get a lot of stars when people find you, and then you will wonder, how did people find you? Where did everyone show up? Usually when project gets stars, it's not a smooth curve, it's just these events in your lifetime. And you can chart this, and then you wonder, why did so many people come here? And what I did here is I joined this dataset with Hacker News, which we also have available in Bigquery. So these annotations are not done by hand, but with a join, I'm able to see the moment this project show up in the Hacker News front page, that's when they get a lot of stars. And then you're able to start looking at different data sets together, joining them effortlessly. This was my Hacker News versus GitHub query.
So are you saying that there's a Hacker News event?
So on BigQuery, I have all the Hacker News articles and comments, and you can analyze them. So here I'm doing a join based on the URL of the Hacker News event pointing to GitHub. And then I'm also looking at the number of stars of the project, and boop, it shows up whenever something, I'm doing my filter for posts that got more than 300 votes on Hacker News. Project health. This is when we're choosing a project, when we want to see if our project is healthy. Let's look at the number of issues, let's look at how many people are filling issues. So for example, this query counts the number of issue comment events. How many comments we had per issue for issues in every repo. And these are the top projects, at least in the month I did it. We can repeat the query now. And again, you start seeing interesting things because everyone knows Kubernetes, Spark, Origin, but Sauron demo, why is this a top project? Why it should be here? Turns out most of these issues are created by one person. So again, we need to bring in different dimensions, and let's look at the number of different people commenting. Another query is here. So we can see that if we get the number of unique users and get the top projects by how many people are commenting, we have that, yes, Kubernetes received a lot of comments, but from 500 different authors. And that gives him a huge number of comments per author. This shows that people in this project that are commenting are pretty involved. They come back. These 500 people in average wrote 18 comments each this month. You also have Visual Code here, Visual Studio, and you have more people commenting there this month, but the engagement was way lower than Kubernetes. Kubernetes is really out of the norm. But still, you can see that these projects on top are way healthier in terms of being able to have conversations compared to Font Awesome that had a lot of people commenting, a lot of comments, but in average less than 2 comments per person. Like there's no real discussion there. And you can go further than doing all these counting stars and analysis that we've been doing. You can analyze text. You have access to all the comments that people have written. So for example, how to start an issue. If we look at all the issues and we look at the first 4 words, people really like asking things in nice ways. It would be nice. It's a good way to. It's a common way to start an issue. Is it possible to? I am trying to. I have the following. And again, if we start looking at more dimensions, we can see how effective each way is of starting an issue. So it would be nice gets 56% of closure, versus is it possible to get your issue closed 73% of the time? Because you are being more concrete on what you want. The best way to get your issue closed here is, I get the following. Being very concrete, asking for, is it possible to do? And of course, there is this weird issue, so that the humans, that it's, that comes also from one project where I didn't filter doing things differently. So that the humans come for one specific project where I should have filtered. But I like showing this stuff up just to reinforce always the thought that, oh, I need to look at my data, I need to calibrate it by number of different people or by number of different projects. We can run the query now. Let's see. Let me see if we can get that results here. So BigQuery used to have its special kind of SQL. Oh. Why did my copy-paste query not work? Oh, trailing comma. So SQL has this problem where you cannot put a comma at the end. Like C# has no problem with that. You can, but with SQL, if you comment a line, then you have to delete the comma, and it drives me crazy, but you have to do it. So yeah, here we have the ranking again. And now if we look at, in this case, I want to do the issue ID. What's the max issue ID? Because every project counts the issues it has. So for example, the max issue ID of, this shows me that these are projects that are getting a lot of comments. But then if we go to So That Be Humans, it's all, at most the second comment that a project gets. So yeah, this, it's a sample thing, and maybe it's in a lot of projects, but it's always the first project is a beginner thing, and we can filter it out in that way. Filter out the first comment or the first or the second one. And then we can start, as I was telling you before, with GHTorrent. We can see the profile of each user, so we can see the country. So now I can count for, I can go to the GHTorrent table, and I can find that the country with the most users is, of course, the US, interestingly enough, then India, then China, Great Britain, Australia is here, number 11. Not bad. And of course, you can chart, and this is the chart by number of pushes in X month, August 2016. Now, this kind of ranking is not very fair, because of course, the US will have the most number of pushes. Again, we need to look at data in a critical way. So what we might want to count is number of pushes per capita. And now the chart changes. Now you can see that, yes, the US and Canada are pretty equivalent on the number of pushes per capita. And then North Europe is stronger than South Europe. Africa has a very low count of pushes by people pushing by capita. And Australia is doing pretty nicely. Again, we can do the ranking, and we can find that the top countries, number of people pushing divided by population. So that means we have a high concentration of developers. The top one is Iceland, and Australia is here, looks pretty nice, between the UK and Luxembourg. But interestingly enough, the second one is New Zealand. That's a lot of developers there. Anyone knows why? This is my first time in Australia, so I need to ask questions. Anyone from New Zealand here? Oh, cool. Oh, okay, makes sense. You like coding. That's awesome. So the next question, if you see this map and you see these cold places having a lot of developers, you might wonder, well, maybe developers really like cold climates, or do they like hot climates? Again, we can join data sets. I have weather also on BigQuery, so I can look at the weather for the whole wide world last year. This is the average weather for each country according to my tables. We have Australia around here, which has, it's weird to look at the average weather of a country because a country has a lot of weather, different climates. But it kind of makes sense when I do an average and look that, yes, of course, Australia has a wider range than other countries, but you could say that this is its position in the world, and now that you have an average value, you can join it with my other values, and this is a ranking. This is plotting temperature. This is the temperature here. These are the hot countries. These are the cold countries, and the ones with the most developers per capita. Of course, Iceland is here on the top, and it goes down as the temperature goes up. But you have some outliers. So, for example, Singapore is super hot, but on top. It has a high concentration of developers. If you like hot weather, go to Singapore. You will find a lot of coders there too. And also Australia is an outlier. Like, it has way more developers than we would predict by climate. So Australia is a pretty good place to find a lot of developers and warmer weather than Iceland. Something pretty interesting here, I colored my stuff by continent. You can see that every continent follows the same trend. Like, we have New Zealand, which is the colder one, Australia, and Fiji here for Oceania. It goes down with temperature. But in Asia, things go up. The hottest countries, Singapore, the United Arab Emirates, these have the higher concentration of developers. I wonder why. They like AC. Since you have this data, you can look at the top GitHub projects per country. What are the projects that people from each country are starting? And then again, we have a lot more regional interest projects. So this is from looking at Asia. The top project that's started only by Vietnamese people is Awesome Jobs Vietnam. And each country has its own idiosyncrasies. Let me see did I run the one for Australia? Yes. So for example, these are the top projects started by people that say they're from Australia. Relax, JetWatch, React Select, Svelte, Keystone, Flow. What is interesting here compared to many other countries is that the projects Australia is starting are not very Australia specific. Like, I didn't find like something that was Scream Australia here. Well, other countries do. Something you recognize?
Yeah, the last one we played Music Desktop.
Uh-huh.
Was done by a student I taught.
Uh-huh. So Australian student made the 10th one. See? So sometimes you have this thing with projects that you want to make them popular, but the first place to get stars is locally, speaking at local conferences, showing your project around, and a project that might be interesting for everyone around the world will start being interesting first where you live, in your university. And this is a really nice tool for people that are developer advocates like me, because I travel to a country and then I can see if the project I was talking about got more stars in the country I went to. And then I can justify to my manager flying there. So yes, start my projects today, and then I will say that Australia is doing things. I still have 30 minutes. Let's look at the code now. This is really interesting. We were looking at stars, metadata. Let's find all of the code inside Bigquery. We published this a year ago. There were a lot of Googlers and people from GitHub collaborating to make this possible. We had to set up a huge pipeline. But now you can find the contents of GitHub inside Bigquery ready to be analyzed. So when I took this screenshot, this was back in January, we had 213 million different files, 1.79 terabytes, but let me look at the contents, GitHub repo contents. Right now, I have 2 terabytes of code in 240 million files. And I mentioned that we have a lot more code because what we really have here is the number of files, but each file is only stored once, each unique file. So if I want to get my total number of files, I can do the sum of the copies. And if I want to see the total number of bytes, I can see the length, the size. So what these 2 terabytes and 240 million files really represent a total of, wait a minute, I'm adding 240 million numbers, multiplying, and it should be faster. Can I blame the Wi-Fi? No, it's there. Yeah, this is 50 terabytes, bytes in terabytes. I love Google. Yes, it's 50 terabytes of code that we can find here. And again, we can start doing interesting analysis. Now, some rules when you're getting ready to analyze this. First, this is the main table. Each file has an ID, a hash of its contents, its size, the content itself. If it's an ASCII file of less than a megabyte, and the number of copies. This is the multiplication I did. And the first advice I can give you when you are analyzing a table of 2 terabytes, since the cost of the query is per query, you want to reduce the size of the table. You want to go from the 2 terabytes down to something way smaller, which could be, for example, extracting all of the C# files, or extracting all of the Java files, all of the JavaScript files. And then you can run your analysis over the way smaller table. I left some tables that extract like that. For example, this one, sample contents, has only 10% of the contents for the top projects and 1 sample path per file. So if you're going to start analyzing in mass, start with the sample contents table, develop your algorithms, and then go for the big one. It only has, we will only see projects that have an open source license and that GitHub can detect that it has an open source license. So for example, this one has an Apache 2 license. If we go VS Code, GitHub, Visual Studio Code, it recognizes that it has an MIT license. But there are some projects that don't show up. So Apache Spark, finally they fixed it. Sometimes GitHub cannot recognize the license and the project will not show up. It's funny when Apache doesn't have an Apache license, but things are getting better. So for example, let me give you an example from Java, the top imports. If I want to find, sorry for doing Java in a C# conference, but we can do C# too. Here I extracted all of the Java files for 2016. I'm splitting each line for each file, and then I'm looking for lines that start with import. And that will show us, just by analyzing code, what were the top imports on files from 2016. As you see, this file is not, this table doesn't have 2 terabytes of code, it has only 12 gigabytes, which is much nicer to analyze. And yeah, interesting, we get the top imports, which makes sense. A lot of people testing with JUnit. That is a nice thing to see. But then we can start comparing by year. We can look at, in this slide, for example, I'm comparing the top imports from 2016 compared to 2013. And then you can see what libraries are growing more popular, which libraries are losing popularity. It will reflect on what's the state of the code. Now, of course, let me do it with C#. I also I left these 2 tables for you. I made them last night. All the CS files and all of the packages config. So if you want to find the most popular new NuGet files. You can analyze this one. If you want to analyze the top, all of the C# code, you have 31 gigabytes of code, and we can do things like, by the way, when I did my extracting that you don't need to do, I also added more interesting columns because, the first thing you can do to extract is give me all of the content where the ID is in files that end with CS. But I went further, and each of my extracted rows also have the number of stars that that project has, the number of stars in 2016, a sample path. So you can look at the popularity of each file, at least for the top project where that file belongs to. So then we can do things like, let's split things. Let's look for the files that start with using. Let's count the distinct from repo, and we can see that generic is using 100,000 projects, interop service, LinkU. And of course, the top imports come from system, but you can go further down with any dimensions that you might want. We could find what are the top imports in Australia if we wanted. I just didn't do it last night. But if we have time here, we could do it live. Also, Stack Overflow. A lot of people use Stack Overflow. I do, you do. And with a query like this, I can go and find, for all of the code in JavaScript, what are the top questions that are being pointed in the code. So for example, this, if you go search in GitHub's code and you join it with Stack Overflow code, Stack Overflow data, that is also stored in Bigquery. You can find that in JavaScript, the top linked question is if there is a regular expression escape function in JavaScript, or etc. And of course, C#, there are 189 files pointing to the question WinForms big paragraph tooltip. Why this one, I don't know, but you can also see the number of views that each question has. There are, for example, 88 files pointing to what is the best algorithm for an overridden system object get hash code. There's a lot of people looking at that question, linking to that question, and maybe that's good feedback for the visual, for Microsoft to incorporate these kind of things so people don't need to go to Stack Overflow. Also, with a lot of views, even more views, a lot of people want to know how to randomize a list. And that would be a nice thing maybe to add to the API, whoever is designing the language. Yes, there's a lot of people that need to do this, and they have to go elsewhere to find the answer. And Sebastian did an awesome project where he started looking for people that copy-paste code from Stack Overflow to GitHub. Hi, you've done that. So yeah, so this is one of the most popular questions. It has been super voted. So he wanted to know how many people have copy-pasted this code in their code. He took it. Of course, if you search for this literally, people change it in many ways. They might change the indentation, spaces to tabs, etc. So he reduced this piece of code to a regular expression that follows a structure, and look, it doesn't even have the name of the variables. But yes, he found this piece of code in 448 different files, and only 97 of them, 27% of these files, gave any credits to Stack Overflow. And this might be a licensing problem, so be aware. People can find when you copy-paste code, at least put some credits there. Requesting features. This is from when you want to change the API. If you want to tell your favorite language to add a different, an easier way to do things, to randomize a list. This is from the Golang list. Someone was asking, I want to be able to write this after time until instead of after expiration times up time now. Nice request, but how, as a project maintainer, how do you choose if you want to do this or not? In this case, my teammate Francesc went to Bigquery, ran this query, and found that 2,000 repositories would benefit from this with this change. So the Go team saw this data, saw that a lot of people were doing things in an optimal way, and they added a new, easier way. So this is another nice thing about doing open source now and putting your code on GitHub. You get to vote. Just by putting your code there, people can count your code as voting for features that could benefit you. Same thing, someone wanted to, so that TLS config had different capitalization on different Go packages. And Frances found out that 685 repositories would break if they made the capitalization uniform. So far, no one has done it. But code a vote. Now, you can go further, like we're doing a lot of SQL here. You can also, with regular expressions, etc. But you can even use JavaScript inside the queries to do whatever kind of analysis you want to do. You can have your own user-defined functions. So one of article I published is doing JavaScript code analysis inside a SQL query. JSHint does static code analysis. It's a JavaScript library, which I pointed Bigquery to. Like Bigquery uses this library, and then I can do things like inside my query, inside all of my JavaScript files, run JSHint, look for the errors you can find in the code, and yes, I get results. I get that a lot of lines are missing a semicolon, that some variables are not defined, which you can do in JavaScript, but still might be a stylistic problem. Expected something instead, so something. So I find it really amazing that I can go really deep into analyzing code, analyzing text also, if I wanted to do natural language processing inside my queries and do it on scale. Just to start wrapping, tabs versus spaces. Tab people here? Spaces? Everyone else? Agnostic, whatever the IDE does.
Whatever the project is set to.
Yes, well, makes sense. So I ran this ranking. And this is where all this talk about stars matter, because instead of looking at all the code on GitHub, because there's a lot of code, I only looked at files that belong to projects that have a lot of stars. So I look at the top 400,000 repositories by stars, and that's the code I was counting. Files with more than 10 lines. Each line gets one vote. If a file has mixed spaces and tabs, I choose whatever is more popular, and I did it for the top languages. First, of course, I extracted all of the data I wanted. That takes a long time because it has to materialize all that data to a new table, but then I can run this query that we can run here just to make it more fun. These are my rules. I didn't write this query with standard SQL. So yeah, you can see I'm counting the number of lines with spaces versus tabs. Whatever is the maximum is the best one for this one, 12 seconds. And here we have our data. There are better ways to visualize this, so let me save to Google Sheets. I just like doing this just to show how fast we can do stuff. And to make it prettier, let me copy. No. Let me copy this table. I want to make every number, all the tabs, bring it to negative space. So I will copy this here. Pop up. 1 second, please. Tabs -1 plus times v2. Perfect. Now this is negative, and now I can go and chart this stuff. Come on, Google, chart it for me. Chart. Too many columns. I only want to count by extension, tabs versus spaces, so each language gets its own count. Insert, chart, and I want to do stacking so things look better, standard, and I want to do it vertical, stacking, standard. And here you have the percentage of people that do files. We're counting files. yeah, in Java, it's way more spaces than tabs. C# also prefers spaces. And there are languages like Go that are all tabs because they enforce it. And C has 50-50. And we can find things. I got a lot of views for this post, but at least it's settled that people today prefer spaces if you like tabs. Go is a safe place to go or to stay with the C people. So this is my chart. Another interesting project. This is some Googlers discovered a huge security problem that was pretty nasty, and they went searching with Bigquery for all the projects that were having this issue, and the 50 volunteers sent patches to all of these projects and fixed the security issue, which was pretty cool. You can read that article. And the last one I want to show you here is about the commas. Which one is on that side? Which one? Who likes the trailing commas? Yes, of course. And who likes the leading commas? Yes. Okay, so I find the leading commas horrible, but that's the one I use. Because SQL doesn't allow me to have a trailing comma, as you saw my error earlier today. So I would say that even though this is uglier, in many ways, less natural, it's more efficient. What I want to prove is that. Can I prove to other people that this is more efficient? Let's try to do that. So first, I went looking for what was more popular. If you can see trailing commas on the bottom here. Come on. Yeah. On the bottom here, I found 50 million lines or 5 million lines of SQL code that end with a comma, while lines that start with a comma are way less popular. And there are some people that put commas at the start and at the end of the line. I won't judge them, but yes, there are a few, a very small minority. So if you wanted to judge by popularity, of course, you put your commas at the end. But I want to search for what's more efficient, what's best for projects. So the question is, how do you define that a project is more productive? I could count the number of stars, the number of people contributing to the project, the activity in the project, the stars they got last year, whatever I want to define as my success metric, what's more successful. And the query was way longer because I wanted to count all those things, activity, number of stars, etc. And my final result was that there are most projects do trailing commas. Some projects have no commas at the end or the beginning, just at the middle, which is nice, but then you're not breaking. Some projects do both. Sometimes they have leading commas, sometimes they have trailing commas, and a very few minority are very strict and only have leading commas. And in all these dimensions, I found that projects that allow leading commas have more stars in general. Last year, this year, the number of people contributing, like 11 versus 5, or activity, like 156 events versus 43 events in average for the projects that were very consistent on not allowing leading commas. So this is a way that we're showing people that letting developers figure out that, one, SQL has a limitation. It doesn't allow us to put a trailing comma. Then they have to figure out, oh, my life will be better if I put the commas at the beginning. And then the project allows them to do that. Those projects are healthier. Projects that allow you to do what the developer wants instead of enforcing a standard just because. So yes, who wants to analyze GitHub? Hopefully all of you. I have this video with Alison. She works at GitHub, and she also uses Bigquery to analyze and understand their own company. It's a pretty good video if you want to watch it. Hopefully you will want to do this. And there's a lot more people writing stuff, doing analysis. I collect everything I find around. Tomorrow, Sarah is giving a talk, another talk on Bigquery, more analyzing bikes, the real world. But so if you want to see more BigQuery, go see her. And if you want to find me, you can find me on Twitter. You can find me on Reddit. You can find me on Stack Overflow. And if you have any feedback for me, please feel free to leave me anything. And that's basically the talk. Any questions? We have like 9 minutes. Yes, hello.
Are you going to have these slides online?
I should. I'm very bad at cleaning them up and putting them when I should, but please insist me, and I will. Now, most of the things I talked about are online. So if you go to my Twitter, my Medium, Reddit, you will find just not in this sequence. But yeah, my business is publishing.
Sorry, the data that you're looking at, I'm confused. Was that part of your own account, or is that actually just one data set that's public?
All these tables are public. So if you go to this URL and you have an account, creating the account might not be the easiest process, but if you don't need to put your credit card, if you follow the right steps, you will be able to land here and start writing any query in the next 5 minutes.
Who owns this data set? Is it GitHub that's maintaining it?
Well, so the 3 data sets are maintained by different people. 2 of them are maintained by Googlers, GitHub Archive and the contents, and GHTorrent is an academic project.
But there's nothing stopping you from having your own.
No, yeah, you can make your copy, and to get all of the copies, we consult. To copy all of the contents, we consulted all of the lawyers, and that's why we verify and only move open source code that we can detect that has an appropriate license.
So this is like a query APIs that can connect to any data source. So I can connect it with like my company, like the data source, and then starting doing some queries on this one.
Yes.
Or
So the question is, what happens if you want to run this BigQuery on your own data? Yeah. Excellent question. You can load your data to BigQuery, which is also pretty easy. So you can, if for example I wanted to create a new table, I create a data set and I can tell it create new table, which will read data. Oh, where is my UI? Create new table. My UI is not here. Oh, here it is. Create table. It's not a pop-up anymore. I can load file data directly from the web up to a certain size, or I can put my files on the Google Cloud Storage. I will ingest this data. And once it's inside BigQuery, things will run as fast as you have seen it here.
okay, but you said at the beginning that you can run it against your data set in like Power BI or like SQL or whatever.
Oh.
So I can connect it like my Azure account, and then I will pull some data doing some query.
So what you can do with Power BI is once your data is inside here, you can tell Power BI read from BigQuery.
But I can't run these queries against my like data when it's reside outside.
Yeah, no. The secret is to move the data inside, and then once it's in BigQuery, there are a lot of tools that can talk to BigQuery, including Tableau, including Python.
Yeah. And what about the security of my data if it's like contain sensitive data?
Yes, that's a good question. What happens with your sensitive data? We have all of the ISO certifications that can ensure you that your data is private, it's encrypted at rest, you can only see it. We have all the audits to show your manager or whoever is deciding that yes, data is secure when you store it here.
Thank you.
Yeah, no, thank you. Hello.
If I wanted to capture my private organization's events, are there some open source tools that allow me to capture it in exactly the same shape that you are using for your queries?
Open source tools to capture data into BigQuery. There's a lot of tools, yes. You can even stream data in real time if you want.
Or the GitHub repo data?
To just take GitHub? No, so the specific GitHub, we did it in partnership with GitHub because if you want to extract this much data from GitHub, it will choke. Like the API, it will stop you from extracting so much data because it might be abused.
If it's just my organization, a private subset that's not big, but
Oh, yeah.
I will listen to the events and save them the same way so that I can use the same queries that you have.
Oh, that would be pretty interesting. I can talk to the person that wrote the pipeline at Google, so we could document it and have it. But it's basically, yeah, even if the schema is not the same, it's pretty easy to just change the query to adapt it to what you have. Thanks. That sounds pretty interesting too. Yes, please.
Upload time aside, how fast is the ingestion process?
The ingestion process on BigQuery is pretty fast because we are able to, if you put, regardless of the size of the table, we can, the ingestion process splits it between a lot of computers doing it in parallel. So one way is streaming data. That will get you the data immediately into BigQuery. You can start writing queries immediately. Or in batch, it might take 2 or 3 minutes. Sometimes I just do it on the stage just to show that it's really fast to get data inside.
So those batches talking gigabytes?
Yeah, so if you have 300 gigabytes of data, I can see it being ready to be analyzed in 5 minutes. Sometimes it's less, sometimes it's more. It's variable, but it's pretty quick. Yes, no problem. And by the way, another nice thing about BigQuery is that you don't need to think about indexes, partitioning, distribution. You just show your big file to BigQuery. BigQuery will ingest it, and no indexes were needed for any of these queries. Everything is a full column scan. Since there's a lot of nodes running, things scale fast without you worrying about that. Yes, please.
Could I get you to run a live query against the dataset and find the most starred repos in North Korea?
The most starred repos in North Korea. There are not many.
It's weird on your metrics for like users. So starred repos by users in areas. So
Yes. So
only data there for them.
I have for South Korea for sure. So when I want to run this type of queries, I go to my articles, so top, GitHub, projects per country, and I just copy I look at whatever I publish first. So South Korea, the top project there in South Korea is Seoul OpenGov, but you want to see the stars for North Korea.
Yep.
We have 2 minutes. Will we manage? Let me see. I can copy my query. This is just to show you that anyone can go to my Medium post, take the query, paste it here, and let's look only at where is my country code? Let's see. Where c.iso equals nk. I'm assuming that's the code for Korea. There's a oh, yes, that's a bad query. Ta-da-ta-ta-ta-tan. Probably my filters will leave that country out. Let's see what happens. So what I'm doing here in this query, I'm taking all of the stars for 2016, all of my actors, and the query returns 0. We can do this. The first question is, what's the country code for North Korea? Is
KP, PRK, it's got KP.
yes?
Is it a ISO 3166?
Yes. So how many letters?
2 KP.
KP. Okay, let's.
There's also another one that says PRK.
Yeah. No, I need the 3-letter code.
PRK in that case.
PRK. Okay.
Korea.
Yes. Where country code equals. Where c.iso equals PRK. Will we get results on time? suspense. So yes, again, what I'm doing here is combining these two tables, and it's not returning anything. What I'm doing. Yeah. I will put here country codes equals PR key. Let me do an even smaller query just to get what I want.
Look for red stars.
Yeah.
In North Korea, Rico stars you.
When the big query doesn't run, just try smaller sets to see if you can get anything at all.
Can you search GitHub users to get that data set?
Yes, so that's this table, which has the data in create effect, delete country code. Oh no, sorry, it's the two. I don't know why it's moved to the 3-letter code. Oh, that was to get my map. So, what was the 2-letter code? KR. Korea. And watch events in 2016 by people from Thank you, everyone. I love pair programming.
But did I have internet?
Yes. Now we can select. Oh,
Probably this is the only one that has internet.
That's there. That's
yes.
GitHub.
Yeah, no, I need to order by stars desk. And if I don't do it now, we have to vacate the room, but I can tweet about it later because, oh, okay, yeah, whew. Free Code Camp, of course, TensorFlow, Seoul OpenGov. Are you sure this is North Korea, not South Korea? Yes. Aha, okay. North Korea ISO code 2. KP. Okay, last query of the day. At least we're getting results. And we're getting results that make sense. Ta-da! Poke. Thank you. They gave 2 stars to Poke, which is a robust, elegant, feature-rich template engine. Thank you very much. Have a great day. Woo.